Hey everybody, welcome to Vology's Wireside Chats. I'm your host, Neil Teresiano. I'm here today with a really good guest of ours from Nutanix to cover our third of 4 episodes on converged infrastructure. So I have with me James McNiel from Nutanix. James, thanks for coming. I appreciate it. Before we get started, first of all, I think this is your third visit with us, right? So we probably have a few fans that like hearing what you have to say. Hopefully they're on this right now to find out a little more about Nutanix. Today we're going to be a little more technical. That's why we brought you. So why don't you tell us a little bit, once again, for the group, what you do for Nutanix.
Great. Yeah. Thank you, Neil. So I'm a senior systems engineer with Nutanix. I cover the state of Florida, and at the risk of making any enemies in the audience, Bermuda as well.
That stinks.
So I basically go out and evangelize the product. I go out and help educate customers. I help educate on how we can help them in their data center, how we can really bring them into a converged infrastructure and really simplify their data center.
Cool. So, there's a lot to talk about. We have a very little bit amount of time to cover it. And folks, just so you know, the purpose of this one is to be a little more technical. On the first episode, we were a little high level, so we're going to get a little deeper dive on this. Be sure to hit us up with any questions you have along the way. We're going to try to keep as much time as we can at the end to answer some questions. I know that Nutanix does drive a lot of questions as sort of a disruptive technology, so be sure to keep hitting us early for the questions, and we'll take a look at the chat board and watch to see if any of them come through. So, Jim, real quick, before we even get started, let's go over the portfolio a little bit from Nutanix. You guys obviously push a lot of iron, right? I mean, it's the whole base of this is the commoditized piece, right? Not just the software and services that are associated with it. Can you run us through the hardware portfolio at a high level and just give us some ideas of what we're looking at when it comes to the hardware we can get from Nutanix?
Absolutely. So we offer the terminology that we use at Nutanix is a block and a node. So a block is essentially the enclosure. So all of our blocks are going to be a 2U footprint.
Okay.
And then within that 2U footprint, we have various node models with different configurations with SSD. Different memory configurations and more importantly, different storage configurations that dictate how many nodes are going to exist inside of that block.
Okay, so it sounds like through the hardware pieces, we've got configurations that would be up to 4 nodes. You said, right?
Up to 4 nodes. And
down to 1.
Down to 1. Again, depending on what the requirements are, what the needs are, and what type of storage footprint.
A little more tailored, then, right? I mean, so. Is it possible? I mean, I got to ask the question: if I get a 1-node or a 2-node box, is that upgradable, or am I looking at another block?
So typically, it's linear scalability. So typically, you're going to grow a node at a time. So all of our node configurations are typically it's a preset configuration, right? We have different models with different processor types, different SSD capacities, and then the only real item that's customizable would be the RAM.
Okay.
And it's meant to be simple that way. It makes purchasing it simple. You know exactly what you're looking for.
Right. It's part of the reason why we did it, right? It's for the Lego block scenario. I know you're
absolutely Lego block's a good it's a good analogy.
So
we have a customer that just is standardizing globally on Nutanix, and they call it Project Lego. So
that's
cool. It's great.
So the 1-node piece, does that give us more options then? Because I know there's a lot of VDI. Nutanix is getting involved in a lot of VDI. So that means PCI cards.
It
Do you have that? Okay.
Yep. So our 1-node model is we refer to it typically as our GPU node, which supports the NVIDIA grid cards.
The K1s and K2 cards.
Yep, as well as the Teradata Apex cards for VMware users.
Wow, cool. So let's start off with my favorite part, right? I love storage. Storage is one of my favorite topics. So if it's all right with you, let's talk about some of this, because I do know this from practice that we did have a customer that purchased Nutanix from us, because Nutanix can also sort of slide into the environment as a storage solution only, right, to some degree, because it can present externally itself as a storage target, right?
So we don't typically support that. We're actually going to be a storage and compute player. Platform, right?
So if we're going to do that, we need a virtual machine that's presenting, that storage externally.
We're built around virtual machines. And really, if that was a supported configuration, you would lose a lot of the benefits of Nutanix, such as features like data localization, where things are internal, where we're taking network bottlenecks out of the mix, and it significantly reducing storage latency, really giving you a much higher level performance.
Well, let's talk about that. So you have 2 arrays set up in the box. You have a hybrid scenario. You have a heat map on one array, and then you have, I guess, the slower stuff on another array. How does Nutanix set that up?
So inside of the actual Nutanix cluster, so all the drives that are physically attached to the various nodes in the cluster are going to have some type of SSD and some type of SATA component. So it is a true hybrid solution, for that price to performance ratio. In a side of a storage pool, we're going to take actually both of those platforms, right? The SATA and the SSD are going to coexist in the same storage pool, but we're going to tier them. So they're separated off as tiers under the covers. So this is something that the users, the customer does not have to worry about. It's nothing that they have to configure. It's going to be fully automated tiering right out of the box.
So tell me a little bit about the array configuration internally. If I lose a drive, just before we depart from the storage piece, if I lose a SATA drive, or if I lose an SSD in a given, we'll call it a block, right? What's happening? Is there a rebuild time? I mean, is this any different than my normal server configuration? Is there something to learn here from a hardware management perspective?
Absolutely, yeah. So in the event you lose a drive, we don't actually leverage RAID, traditional RAID. We leverage what we call replication factor. So basically, with replication factor 2, for instance, your blocks of data live in that Nutanix cluster in 2 places. And that's going to be on separate nodes, separate drives. So in the event you lose a drive, and we mark that drive offline as failed, we look at our metadata, say, okay, what blocks of data were on that drive, and then all of our virtual storage controllers participate in a rebuild process, and we redistribute that data across the rest of the cluster and rebuild it. One of the big advantages of doing it this way versus RAID, now that we're into 4 terabyte drives, 6 terabyte drives have just recently came out. In the event you have a 4 terabyte drive in a RAID 5 or a RAID 6 configuration,
takes forever to rebuild.
You're looking at 48 hours to rebuild that, at which point you're crossing your fingers hoping something else doesn't fail, or you're going to be dead in the water and suffer potential data loss, be starting to pull
right, you can only answer that with more disks, right? That doesn't save you any money. So this is really interesting. So it's a JBOD box, right? There's no RAID control happening inside that box. This is all sort of presented to your platform as an available set of storage, but it's not in a RAID array at the hardware level like we're used to seeing in a 2U server.
You're right. Yep. So it's basically, a drive's connected to a SCSI controller.
Okay.
All of that intelligence is built into our software, where we believe
software RAID essentially, right? But sounds like distributed over the network essentially instead of internal to a given box.
Yes, distributed amongst the nodes in the cluster.
That's very interesting. So that's going to lead me to the next question. A lot of people are going to ask, right? We're used to offloading that workload for handling a lot of that, to a RAID controller that has that set up. Am I moving that traffic to my network? Explain to me the benefit or the value in staying JBOD and going to software RAID.
Well, again, the first is obviously that rebuild time, which is important.
Yeah.
We're single-digit hours versus potentially 2 days. Big advantage. We see a lot of these hardware cards as being single points of failure, right? So a RAID controller typically on a server today, if something goes wrong with that RAID controller, you're suffering some type of
catastrophic,
potentially catastrophic issue. So with it being that software layer, it's one less piece to actually to fail and potentially cause any kind of outage or downtime.
That's interesting how things are cycling, right? I mean, and then we're going back to just JBOD, and we'll leave it up to software to figure out that sort of fault tolerance that exists. I mean, that's really exciting. So you mentioned another word, data localization. Can you explain that to us? As I understand, data localization is meaning that data that virtual machine needs is pretty much on the same NUMA node, essentially, or on the same node that box is on. Is that what you mean by data localization?
Exactly. Yep. Exactly. So, obviously within the cluster, you've got a tier of SSD drives, you've got a tier of SATA drives, but we take that a step further. So we actually take the working set data, so the blocks of active data on a virtual machine, and we localize that data. So that's behind the scenes, under the hood, we'll actually move those blocks of data around within the cluster so that they're running on the local SCSI controller, on the local SSD drives that the virtual workload's running.
Oh, wow. Okay.
So you're basically running, SCSI bus SSD performance for your virtual machine at that point.
Doesn't have to stay like that, though, right? I mean, in a case where that's not a possibility, will your software make the decision to allow it to reach across the network or to another node on the box, or however it's deciding what's local and what's not?
Absolutely, yeah. Okay. So in the event of, say, a vMotion, for instance, as a machine moves over to a different host, that localization over a period of time will slowly,
it'll migrate over.
Yep.
It's still reaching across the network to the other shared. It's really shared storage. Each box is shared storage essentially, right? So it's still reaching over, but as it builds that localized piece, right, that profile, then it'll start to point over to the local piece.
Exactly. Yep.
So it's a sort of an affinity, a storage affinity piece. That's really cool. That's really interesting.
Yep. That's just working set data. So that's not a storage vMotion. We're not taking say a 50 gig virtual machine.
So your heat map essentially, is that what you mean by working set data, or?
Right. The active blocks.
Okay.
So a very small fraction, small subset of that VMDK for in the case of a VMware virtual machine.
The hotter blocks are going to be moved locally. So that's actually pretty cool. That's pretty exciting. So that means that there's a big brain somewhere that understands where the hot data is and where the virtual machines are. Are you guys the big brain? Is that the piece, or?
We are. So I mean that is a function of our distributed file system. At the
your distributed file system.
Exactly. At the end of the day, we're a software company, right? We have the real value add, the intellectual property of Nutanix is that distributed file system and all the features that we provide and data localization. To put it in perspective with the hardware, it's impressive hardware.
That's where the value is.
But we go to the ODMs, provide them specs, tell them, hey, build it out for us. And then we layer our distributed file system on top of it. So it's a big part of our architecture is that commodity Intel servers under the hood and putting all the intelligence in that software layer.
Very proprietary, right? So that's good, right? You guys aren't just a hardware company that does technical services and puts things out the door. So this file system is completely proprietary. It's not an open system that others can use. This is something that you guys own. It may remind us of another file system, I would assume, but can you expound on that at all? Or, I mean, how will we, when you talk about this file system, can you compare it to another one?
I can. So I guess maybe the best way would be to explain a little bit where our DNA is at. So about 5 years ago, two of the guys that actually built the Google file system left Google and formed Nutanix.
Ah, okay.
So they actually brought over with them two kind of fundamental concepts that they were able to solve a lot of their challenges at Google with. The first being commodity Intel servers. So again, no RAID controllers, just commodity, right? It's storage, compute, right?
Right.
And then layering on top of it a distributed file system and really putting all the intelligence in that distributed file system.
That's really cool. So closely related to Google file system. We can't call it that, obviously.
No. But Google built that for Google Apps, right? Facebook's built it for all the photos. Microsoft has built it for their cloud offering in the form of Azure. Amazon. So all the big cloud, web scale companies are doing this. We've taken the concepts of this web scale architecture and adapted that for virtualization, for virtual workloads, which has a different profile, right? Different characteristics of how that data gets accessed versus, say, Google Apps or Facebook. For that
you said web scale. I want to ask you about that later. Let's pause on that one because I want to touch on one more thing. I'm very interested in the web scale piece. Compaction, deduplication, compression. Anything going on there? Are you guys doing anything to create some efficient storage?
Absolutely, yeah. So we provide all those features. So today we're doing inline compression, post-process compression, inline deduplication, post-process MapReduce deduplication. So all that stuff's features right out of the box that are built into that Nutanix distributed file system.
Structured data effect. Do you know where we might see the compaction rate? Are you giving anybody some ideas on a conservative number of what we might see with your typical structured data? Do we see it cut in half, 25%?
And this question comes up a lot, and it's always a tough question to answer.
Got to put a box in and find out.
The short answer is it depends, right? It all depends on your data type. It depends on what type of workload you're doing. If you're doing VDI and you're doing, say, full provision virtual machines, our deduplication would probably be, very, very high numbers. Whereas if you're doing unstructured data and you're trying to
images and video, it might not work out so well.
It may not be very well for you.
That's really cool. So how much configuration leeway do I have when I work with you on a design? For instance, one of the weaknesses, right, to kind of give you an example, and we've been very vocal about this at Vology, one of the bigger downfalls, and not that it's a huge one because sometimes there's ways around it, is the fact that sometimes completely tailor the solution for my customer. So a lot of times what we'll do is we'll look at a converged infrastructure solution, and it may be just a little bit or way too much compute, or a little bit or way too much storage. So I still need to buy several of these boxes. Converged infrastructure doesn't work without, you know, the cluster effect, right? Where we need to have several of what you call block, or we have several machines or servers or whatever that we're using. So a lot of times we'll end up with too much storage. We're investing in too much storage. Or the other way around. I have too much compute, or I'm investing in too much compute to get to the storage footprint that I need. Do you guys have a way around that for us? Because I think I've heard something about it, but I'm hearing it in some of what you're saying. 1 node to 4 nodes. So the question is, am I able to do that? Can I tailor this a little more closely to a customer's needs when it comes to designing a solution?
Absolutely, yeah. So we go through these sizing exercises on a daily basis, where a customer I'll talk to a customer, and they're looking for X number of usable terabytes of storage, and this X number of cores, however many gigs of RAM, and we can build a solution around that. The beauty of our solution is it is very modular. It is kind of that building block mentality,
sure,
where all of these nodes can coexist together within the cluster. You can grow based on whatever you're looking for. And part of our architecture that really provides this linear scalability is the fact that as you grow, you always add another node, which is going to give you some storage as well as compute component. And it's part of our architecture. We run a virtualized storage controller on each node within a cluster, which really helps us out, where you're not doing forklift upgrades as you outgrow a storage processor, for instance. That's how we're able to address that.
So I heard web scale. Let's go back to that one. I'd like to touch on that a little bit. This is something we hear a little more and more of. It's cloud oriented. Can you tell us what you guys have to do with that? Because you mentioned web scale, so I'm not going to put you in a trap.
Yeah.
If there's something going on with you guys in web scale, is there some features there that are available, or are you guys using that?
Yeah, so really web scale is what the big guys have been doing for a number of years. Google, since about 2000 now.
Mm-hmm.
Funny how they didn't, it was very secret for Google for a number of years.
So it's permeating into the normal, SMB and enterprise market finally, but it really wasn't in our language for a long time, and we didn't really use it a whole lot. It's been something. You guys didn't have web scale forever. I mean, you may not have used web scale forever from the very beginning, but I think that there's a lot of us don't even know what it is. Why don't you start with that?
Yeah.
Can you explain what web scale is, and then how you guys might integrate that or use it?
Absolutely. So web scale is what these big cloud providers have been doing. So I've mentioned Google, Facebook, Amazon, Microsoft Azure. It's really, again, building on commodity servers, which is a really fundamental concept, right? Local attached storage, putting this distributed file system on top of it. Again, all these companies have their own proprietary file system that's built around their particular use case. Rich analytics, rolling upgrades, no single point of failure. So just really taking out complexity in the data center. So taking out that 3-tier storage architecture that we've been doing for a number of years, and really just being able to having the ability to start small, grow very large scalability as well. Very essentially, no limit to the size of where these clusters can grow to.
That's great. So there's some scalability that we bring with that, right? And some ease of management that comes around of it. So that takes me to the next piece, management. If I have Nutanix in my environment and I'm managing it, how is that done? Am I using a locally installed client or a web client? Do I have a single pane of glass to manage, or am I running through several things to get some management for my infrastructure?
So we provide up to that hypervisor layer, and we do that all in our web interface. So that's based on HTML5, very clean interface that allows you to manage that storage and compute stack. Again, rich
all under the one pane of glass.
Exactly. And then we've actually recently introduced a feature called Prism Central, where we can actually manage multiple Nutanix clusters, whether they be in the same data center or geographically dispersed across the world.
Oh wow, that's great. Under one frame.
Yep. Log in, hit one IP address, I see an interface, and I'm able to see all of my Nutanix infrastructure wherever that may be.
That's where it's going. That's good to hear. You guys are ahead of the curve on that.
Absolutely. And part of the benefit of our web interface is that we don't have dependencies on hypervisors. We don't have, we're able to support potentially future hypervisors or wherever that may go.
Well, let me ask you about that. That's a question a lot of us are going to have. Most of the time, convergence players sort of kind of keep their hypervisors restrictions a little tight. Where do you guys stand? Can obviously VMware, right?
Yep.
You wouldn't be in here if you guys didn't have VMware.
Absolutely,
right?
absolutely.
So I got to ask you, and you know, Zen Server, KVM, Hyper-V, any of these players?
Yep. So we don't support Zen Server today.
Okay.
But we do support vSphere, Hyper-V, and KVM.
You do support KVM.
Yep.
And that's a pretty big deal, right? It kind of goes along the lines of commoditized hardware, right?
Yep.
Using open hypervisors.
Absolutely.
That's great. You see a lot of customers. Where do you see the customers going? Mostly VMware still?
Mostly VMware. We've seen a lot of traction recently with Hyper-V. So more and more customers are coming and looking at
right?
cost. 2012 R2 has matured a lot as a product.
Sure, yeah.
So Microsoft's finally a viable player in the data center for virtualization. So we see customers going off of VMware for cost, like you said, or different reasons again. But it's definitely growing some traction there. KVM. I haven't seen a lot of KVM with my customers.
That's a subject matter expertise problem usually, right? I mean, it's typically, we're big enterprise might use that, but SMB we don't see it a lot. I certainly don't.
I think a lot of our government users may potentially use KVM more.
Sure, sure. Well, that's actually very unique. I don't know of another converged infrastructure solutions provider, right? Of course, you can buy a Dell box or a Supermicro or a HP box and do whatever you want with it. But when we invest in a Nutanix solution, which is pretty much turnkey, usually the choice is being made for me on hypervisor, and that's a pretty big deal. That's awesome to hear. Any plans for Zen Server? I don't expect it, but I'm wondering if you guys have any plans for it.
It's not currently on the roadmap that I know of.
Okay.
So I would hope we get support for it at some point because it does come up in customer conversations for me periodically.
Yeah, I see it a little bit.
Yeah.
So some more features I think that I think are worth mentioning. I did get wind of a one-click update piece. Maybe you can explain to the crowd a little bit about one-click update, what that is.
Absolutely. So with our one-click upgrades, again, you're going to log into this user interface. It's designed to be as simple as doing an iPhone app update. So literally go in there. You can actually tell it to automatically download the update for you and basically stage it so it's waiting there for you. You hit go, and it upgrades the entire cluster, all the pieces of that cluster in a non-disruptive fashion. So I do this for customers all the time in the middle of the day with no impact to their virtual machines or their environment.
That's awesome.
So
is that a new thing, or have you guys always had that, or?
We've always had rolling upgrades.
Okay.
It's recent that we've actually integrated that one-click feature inside of the user interface. To put in perspective, just to pick on that three-tier architecture again a little bit, you've got HBA firmware, you've got fiber channel switches, you've got storage processor updates, you've got server BIOS, you've got all these different pieces, touch points that you have to manage. And unfortunately, there's dependencies, right? So this storage processor only supports this version of the firmware.
Right.
If you don't get things done in the right order, you could potentially run into issues, or they may
slow down, Nutanix. Seriously, you guys are taking away billable hours from us. Come on now. No, I'm just kidding. I mean, that's great, right?
Yeah,
it's good to hear.
Customers are okay with that.
Yeah, I'm sure they are. It's just a joke. So yeah, I mean, that's great. Goodbye SAN architecture, right? I mean, essentially, we see it going that way with software-defined storage anyway. Right. Things are the network's getting fast enough where we don't really need. The benefits are getting whittled down a fiber channel as we speak, right? With us making faster, lower latency IP networks. Start to run storage through it is just fine, isn't it? So that's good to hear. Some more speeds and feeds real quick. Interface connectivity for you guys, obviously not fiber channel. So 10 gig, 1 gig connectivity?
So we require top of rack 10 gig connectivity. Okay. Typically on most of our models.
Glass and copper?
Yep.
Okay.
Yep. Twin-X and as well as fiber transceivers. We do have a model that's more geared for small business, remote office, that type of thing, where you can leverage 1 gig on that as well.
1 gig copper, just to the top.
Just plug it in.
Okay, cool. And so how many ports am I going to find on your typical box? 2 10 gig ports?
2 10 gig ports. We have 2 1 gig ports, and then we have a management interface per node.
In the 4 node, I'm still going to have 2 10 gig ports, or am I going to have 2 ports per node?
2 gigs per node.
Okay.
So the nodes are fully independent of each other.
Right. Okay.
Each of these nodes, the actual block.
That's what I was getting at, right? So there's no backplane on this.
No backplane.
Each of them are passing through. So if I have a block that has 4 nodes in it, I have 8 10 gig ports coming out of the back of that box. Just to.
Yep.
Okay.
Exactly.
Beautiful. Yep. All right. Cool. Well, that's great. I guess the next piece that I want to ask you about is going to be about the price points for Nutanix, which everybody kind of squirms a little bit.
Yep.
Can you kind of give us just suggested manufacturer pricing let's say that I want to get a pair of low-end boxes, right? I mean, first of all, tell us, how that process looks. Obviously, you're going to come in and assess the situation, or you're going to have a partner assess the situation and make recommendations on size. Let's get past that. Let's just say that we decided we wanted 2 of your lower-end boxes, or do you require 3 boxes? How does that work out?
So to form this distributed file system, you're looking at a 3-node minimum cluster.
3 node, not 3 blocks.
Not 3 blocks.
So I can get 1 block with 3 nodes in it and hit your requirement for availability.
Exactly.
Okay.
And then we would ship that as a block with 3 nodes populated. You'd have 1 empty slot. As you decide to grow in the future, you come back and say, I want 1 more node. You
can pop a node in the block. I don't have to buy another block.
Slide another node in the block.
Okay.
If you come back and you buy a 5th node, we actually send you a block with 1 node and 3 blanks. And there's no additional cost to that block.
So the incremental scale cost is that's a good point. Incremental scale cost is a big thing, right?
Absolutely.
If I just need a few more cores to compute, I don't want to buy another blade chassis, right?
Yep. It's predictable, right? It's very predictable. So, one of the problems that we found that's a very common pain point for a lot of customers is trying to scope out a SAN for 3 to 5 years down the road. You're kind of throwing a dart and trying to hit the bullseye, right? And what happens if you acquire a company or things don't grow as you expected or whatever the case is, or even if it does grow as you expect?
Right.
Yeah, exactly. You've got a 5 years worth of capacity that day one is
at 95%, right?
95% wasted space. It's
You got VMs stunning, you got everything happening. It's a mess, right?
Exactly. So with Nutanix, you start with that 3-node footprint, and then you can grow 1 or many nodes at a time depending on your use case. So you're basically able to grow as it's kind of a pay-as-you-grow model. You know exactly what the per node cost is. You know how much additional capacity it's going to get you, how much more RAM it's going to get you, and it's very predictable scalability from that point.
Cool. Well, I know I just looked up. I see that we do have a question on deduplication. So deduplication, there's a lot of discussion about taking it offline. So I know I'm putting you on the spot, Jim.
Yeah.
And that's the purpose for the questions, right?
Yeah,
so
absolutely.
Hopefully you're prepared. There are a lot of solutions out there, or maybe one that offers deduplication that is set aside on the hardware. Are you guys doing the same thing, or is your deduplication running on an ASIC or some other processor, some established processor to move the workload off of the main structure, the main infrastructure?
So we don't do that. We do it all in the software layer. And really, we look at that as potentially being single points of failure. When you start looking at custom
sort of the same problem with the RAID.
Same idea with RAID as well. So we do it all in the software layer. And part of the beauty is we take advantage of Moore's law, right? So as these servers come out, they bring more cores, more memory, more processing capability, which allows us to easily put more and more features into the software. And just, again, ride that hardware platform as it goes.
So it's an interesting, perspective that I tend to agree with, right? Sometimes it's a little cheaper to buy a couple cores of the most mass-produced processor, right? So let's say you've got an Intel 12-core or a 10-core processor. It's a lot easier and cheaper for us to just add a couple cores to our provisioning and then offload the deduplication, right? That's what you're doing. You're offloading deduplication in the sense that it's doing it, but it's going to pull from my provisioning economics, essentially, right? It might take a couple cores, but I control that now.
Yep.
So that's sort of, I guess, an argument that would be sort of the advocate or the devil's advocate to offloading. Because I think one thing that rings through that on this that I think is interesting, Nutanix is viewed, is there still are single points of failure in most of our server boxes, right?
Absolutely.
So I put a lot of trouble through building a BOM for our customers to make sure I have 2 power supplies, that I have a RAID 5 or RAID 50, RAID 60 array set up. I may, let's say that I'm able to get a deduplication PCI card installed and I can use that, but I'm still flirting with a single point of failure. I could have a power supply fail, sure, and those the mean time between failure on those is a little worse than just chips. But if my ASIC goes that's doing deduplication, I'm kind of SOL, right? I mean, that's an issue. In your case, it's just another virtual machine.
Exactly.
Right. Yep. So it's spun up somewhere else doing the job it's supposed to do. And I think for the array controller, it's very interesting when to take back to our trench of solutions architects and say, hey, we put so much effort in designing things that are fault tolerant, yet we still have a RAID array controller that can fail. I'm not sure I've ever seen one fail, but famous last words, right?
Yep.
I mean, that's usually how that works. You won't know that dedupe isn't working until something catastrophic has occurred. That's really interesting. Value that Nutanix and a different change in philosophy, I think, that convergence is solving, right? Because when you get to pure convergence, I mean, why wouldn't we bring everything and put it on top of the hypervisor and keep it out from the hardware piece? That's a good point.
Absolutely. And we're built for failure in mind, right? We're built expecting that drives are going to fail, NICs are going to fail, nodes are going to fail for whatever reason. It's hardware, right? So these things fail. It doesn't matter any vendor on the planet. These components are going to fail at some point. We're built to withstand those failures, so they're non-disruptive. So when something does fail, your storage is still up and running and functioning just as it was prior to that failure.
So one more question on, someone pointed out you didn't answer the question on price, but we'll let you go on that. Maybe you can get it on the blog. And these guys never like to answer these questions, guys, so that's all right. We'll get past it. What kind of performance do we expect? This is another one you love, right?
Absolutely.
What kind of performance on the storage side do you sort of expect? Can you ballpark us? Are we seeing something in the tens of thousands of IOPS from you guys, or are we distributing it? How's that working out?
Absolutely. I actually like this question because it's a fun one to answer. Again, part of our linear scalability story allows us to grow very, very large from an IOPS perspective. So our flagship model, which is our 3000 series, which is really geared around server virtualization, right, or VDIs is typically where you'd find that. A 2U block with 4 nodes, we're seeing around 115,000 IOPS today.
115,000 IOPS. And this isn't baloney IOPS where it's it's 100% read.
Yep, that's random read IOPS, 115,000 IOPS. The beauty of our solution now is as you grow the environment, as you go back and say, okay, we're going to double this environment for whatever reason, you add a second block on top of that, the entire cluster now benefits with the ability to scale out
on that piece too. Okay, that makes sense.
We've got customers well over 1 million IOPS today in a single Nutanix cluster.
Oh wow, yeah, that's pretty impressive. So, folks, if you do have anything that needs 1 million IOPS, Nutanix,
we got something for you.
I'd love to build something that would need 1 million IOPS. That's awesome. I mean, that's like building a race car. But
absolutely,
folks. I mean, we could keep going on. This format is intended to remain somewhat short. But let me ask you guys to please reach out to your Vology representative. All of them have been trained up to some degree. Obviously, maybe even more than me on Nutanix. They know this product pretty thoroughly, and as a matter of fact, they have access to guys like James that can help answer a lot of your questions on whether Nutanix is the right fit for you, or whether even convergence is the right fit for you, although less and less I find that to not be the case. There's a lot of benefits that come with convergence, so hopefully we're driving that through. This is our 3rd out of 4 episodes on the topic, so hopefully everybody's starting to see that this really is the biggest buzz right now in IT. VDI falls underneath this. I understand that virtualization is a lot of buzz, but that's last year, folks. Convergence is where it's at now. There's a lot of reasons. There's a lot of value being driven by that. There's a lot of disruptive technology out there, and frankly, that owns a lot of proprietary value, right? That's the big important piece. When you're going to look at someone like a Nutanix, make sure that there's a lot of proprietary value in that, or sometimes you're paying for something that maybe you shouldn't. And I think that's a really good point, and I'm glad to hear that Nutanix is making sure that there's still a design process of putting you guys in there, right? We can't walk away from the value of that, and that's a big deal. Obviously, we can get up to 1 million IOPS in a cluster, maybe even more if we design it right. But on the lower end, I think if we don't get to 3,000, you're okay. So you're sub 100,000 IOPS. I just can't imagine a need for much more than that, to be honest with you. So I think that's really impressive performance. Real quick, core density. I know that was the one we skipped on. How dense can I get on cores? Just on a 4-node box, can I get to 12?
So a 4-node box would have up to 80 cores.
Up to 80.
Up to 2.
So I can get 80 cores and 2 U's.
2 terabytes of RAM.
That's awesome.
2U footprint. So the space, power, cooling.
The hyperscale's there, right?
Is great, right? We have customers. I mentioned Bermuda. We have a large customer in Bermuda that figured they're going to save $60,000 a year just on power alone.
Wow!
By switching from the legacy 3-tier architecture down to a converged Nutanix solution.
It's awesome. I wish we had much more time. I really appreciate you.
It's good talking to you about
making it out here. We get a lot of demand, post demand. So maybe folks, you know what? Just post up. Let us know if you want more time on Nutanix. Let us know. We'll spend a little more time on wire side. We'll dive into some specific stuff. Maybe I can convince you to bring a box over here and we can do a little show and tell with one of your machines. Yeah. And we'll get in front of it. We'll tear that thing down as much as Nutanix will let us, and start to talk more about speeds and feeds. So, folks, there's a lot in the convergence, in the universe of convergence going on. Obviously, could probably be a 12-part series. 4th part, we're going to visit HP on something I think on a different perspective on it. But more importantly, remember that we are here to be your trusted advisor at Vology. We're going to always guide you towards the right solution. So far, we've had almost every single vendor in the convergent space, including options if you don't want to go converged with a product and you want to get something designed. But it sounds like there's a lot of value in looking at some of these out-of-the-box technologies that are out there. So do reach out to your Vology solutions architect. Start asking some questions. We'd be glad to get on the phone with any subject matter expert who can help you kind of weave your way through and start to build a path towards convergence. So until next time, fans, I'll see you on the wire side.
Down to one. Again,
okay.
Depending on what the requirements are, what the needs are, and what type of storage footprint.
A little more tailored then, right? I mean, so is it possible? I mean, I got to ask the question: if I get a 1-node or a 2-node box, is that upgradable, or am I looking at another block?
So typically, it's linear scalability. So typically, you're going to grow a node at a time. So all of our node configurations are typically it's a preset configuration, right?
Okay.
We have different models with different processor types, different SSD capacities, and then the only real item that's customizable would be the RAM.
Okay.
And it's meant to be simple that way. It makes purchasing it simple. You know exactly what you're looking for.
Right. It's part of the reason why we did it, right? It's for the Lego block scenario. I know you're
absolutely Lego blocks a good. It's a good analogy.
So
we have a customer that just is standardizing globally on Nutanix, and they call it Project Lego. So
that's
yeah,
cool.
It's great.
So the 1-node piece, does that give us more options then? Because I know there's a lot of VDI. Nutanix is getting involved in a lot of VDI. So that means PCI cards?
It
Do
does.
you have that? Okay.
Yep. So our 1-node model is we refer to it typically as our GPU node, which supports the NVIDIA grid cards.
The K1s and K2 cards.
Yep, as well as the Teradata Apex card and some type of SATA component. So it is a true hybrid solution, for that price to performance ratio. In a side of a storage pool, we're going to take actually both of those platforms, right? The SATA and the SSD are going to coexist in the same storage pool, but we're going to tier them. So they're separated off as tiers under the covers. So this is something that the users, the customer does not have to worry about. It's nothing that they have to configure. It's going to be fully automated tiering right out of the box.
So tell me a little bit about the array configuration internally. If I lose a drive, just before we depart from the storage piece, if I lose a SATA drive or if I lose an SSD in a given we'll call it a block, right? What's happening? Is there a rebuild time? I mean, is this any different than my normal server configuration? Is there something to learn here from a hardware management perspective?
Absolutely, yeah. So in the event you lose a drive, we don't actually leverage RAID, traditional RAID. We leverage what we call replication factor. So basically, with replication factor 2, for instance, your blocks of data live in that Nutanix cluster in 2 places. And that's going to be on separate nodes, separate drives. So in the event you lose a drive, and we mark.
Hey everybody, welcome to Vology's Wireside Chats. I'm your host, Neil Teresiano. I'm here today with a really good guest of ours from Nutanix to cover our 3rd of 4 episodes on converged infrastructure. So I have with me James McNiel from Nutanix. James, thanks for coming. I appreciate it. Before we get started, first of all, I think this is your 3rd visit with us, right? So we probably have a few fans that like hearing what you have to say. Hopefully they're on this right now to find out a little more about Nutanix. Today we're going to be a little more technical. That's why we brought you. So why don't you tell us a little bit, once again, for the group, what you do for Nutanix.
Great. Yeah. Thank you, Neil. So I'm a senior systems engineer with Nutanix. I cover the state of Florida, and at the risk of making any enemies in the audience, Bermuda as well.
That stinks.
So I basically go out and evangelize the product. I go out and help educate customers. I help educate on how we can help them in their data center, how we can really bring them into a converged infrastructure and really simplify their data center.
Cool. So, there's a lot to talk about. We have a very little bit amount of time to cover it. And folks, just so you know, the purpose of this one is to be a little more
for VMware users.
Wow, cool. So let's start off with my favorite part, right? I love storage. Storage is one of my favorite topics. So if it's all right with you, let's talk about some of this, because I do know this from practice that we did have a customer that purchased Nutanix from us, because Nutanix can also sort of slide into the environment as a storage solution only, right? To some degree, because it can present externally itself as a storage target, right?
So we don't typically support that.
Okay.
We're actually going to be a storage and compute player.
Okay,
platform,
so
right?
if we're going to do that, we need a virtual machine that's presenting,
exactly.
that
so
storage externally.
We're built around virtual machines. And really, if that was a supported configuration, you would lose a lot of the benefits of Nutanix, such as features like data localization, where things are internal, where we're taking network bottlenecks out of the mix, and it significantly reducing storage latency, really giving you a much higher level performance.
Well, let's talk about that. So you have 2 arrays set up in the box. You have a hybrid scenario. You have a heat map on one array, and then you have, I guess, the slower stuff on another array. How does Nutanix set that up?
So inside of the actual Nutanix cluster, so all the drives that are physically attached to the various nodes in the cluster are going to have some type of SSD. On the first episode, we were a little high level, so we're going to get a little deeper dive on this. Be sure to hit us up with any questions you have along the way. We're going to try to keep as much time as we can at the end to answer some questions. I know that Nutanix does drive a lot of questions as sort of a disruptive technology, so be sure to keep hitting us early for the questions, and we'll take a look at the chat board and watch to see if any of them come through. So, Jim, real quick, before we even get started, let's go over the portfolio a little bit from Nutanix. You guys obviously push a lot of iron, right? I mean, it's the whole base of this is the commoditized piece, right? Not just the software and services that are associated with it. Can you run us through the hardware portfolio at a high level and just give us some ideas of what we're looking at when it comes to the hardware we can get from Nutanix? Absolutely. So we offer the terminology that we use at Nutanix is a block and a node. So a block is essentially the enclosure. So all of our blocks are going to be a 2U footprint.
Okay.
And then within that 2U footprint, we have various node models with different configurations with SSD. Different memory configurations, and more importantly, different storage configurations that dictate how many nodes are going to exist inside of that block. Okay,
so it sounds like through the hardware pieces, we've got configurations that would be up to 4 nodes. You said, right?
Up to 4 nodes,
down to 1.